Hi, this is Margo. This is Saturday afternoon, May the 23rd, 2020. I'm going to do a sea ice update, Arctic sea ice update. I haven't done one in like a month and a half or so, and so it's starting into the melt season. So I'm going to start doing more frequent sea ice updates now, just to keep everyone in the loop. And I've got a couple of articles to share too. I hope everyone is doing as well as possible. I know it's difficult with everything going on. I haven't felt right since all the earthquakes started down in Tonopah, and it's taken it out of me. But I'm here and doing okay, other than just feeling really tired from all the earthquakes, but hanging in there. So we're going to start with National Snow and Ice Data Center. This is the Sea Ice Index. This is for the Arctic, for the daily, and I've chosen the Blue Marvel view for today. And this is the concentration. If you want to look at the extent, you can just switch there, and the extent is different than the concentration. Extent shows just where anything might be frozen, and the concentration shows where it's more thin, or like the blue. The darker blue is the least concentrated, and the white is totally concentrated. So this is so we're seeing a lot of blue here, and here's the graph for sea ice extent for the Arctic. This is the area of ocean with at least 15% sea ice, and it's this blue line. And 2012 is this dotted line. That was the lowest extent on record before this year, and now this year it had kind of been tying with 2012 during the winter time up there. But since like mid-February, it started really decreasing. So it's the lowest ever. So, and this dark line is the 1981 to 2010 average. So we can see it's the lowest on record for this time of year, and for since like mid-February. And so there's that. While we're here, if you want to look at the Antarctic, here's where the sea ice is refreezing in the South Pole, and it's winter time down there for them in the southern hemisphere, as it's approaching summer for those of us in the northern hemisphere. And we can see it's growing back rapidly. And here's their sea ice extent for the Antarctic, and it's actually doing better than last year. This dark line is for 2019. So last year they were at the lowest in the Antarctic, but this year we're a little bit above that at this point. Here's the Greenland ice sheet today. This is still on National Snow and Ice Data Center. And what we're looking at is in this chart here, Greenland melt extent for 2020. And we can see the red lines where it's gone up, and the blue is the median 1981 to 2010 median, and so this is deviant to that. It's higher melt than normal. So first part of May, we had huge melting of the Greenland ice sheets, and in April we had some. This is melt extent. This line is 10%, so it shows about 5% melt where it spiked there in May. And on this picture we can see the number of melt days for this year since January the 1st, and so far we're in these blue ranges right now, but it's melting mainly around this southern side and a little bit on this western side, and up here on this northeast, and right up here is where it's melting. And this is the daily melt, and we're not seeing a whole lot there. We would see, if it's white, it's no melt, and when it goes into the salmon color, that's surface melt, so we're not seeing that much yet for the daily melt for today, or for the 21st. So there's that. So we'll be monitoring that as well. Now I have, this is from the U.S. Navy website. This is sea ice thickness. This is their computer animated model. This is for today, the 23rd, and it was made on the 22nd. And so here's the Arctic, here's Greenland, and here's the chart over here. And so from this dark purple down to lavender and white, it's 1 meter and under in thickness. The dark aqua is 1.5 meters in thickness, and we see that up here. So we're seeing mainly purples up here on this Russian side, around the edges. When you get into the aqua, the light aqua, 2 meters, and then moving into from aqua to green, it's 2.5 meters thick. Then the green is about 3. The yellow is 3.5 meters thick, and starting at 4, it goes into the red, and bright red is 4.5 meters thick. So let me blow this up a little bit. So for what we've got is quite thin in the Kara Sea, and it's been raining up there. And if you want more detailed information on the rain and the climate and stuff, I do daily reports for my Subscribe Star members, and I show all kinds of different things daily with methane and sulfur dioxide and things from Climate Reanalyzer with rain and sea level pressure and 2-meter temperature anomaly, jet stream, and now snow and sea ice. So that's what I do over there, and I show other things as well. I try to do a daily update just so that we can keep on top of everything that's happening, because it's going so fast. So it's been raining up here, and in the articles that I'm going to share, it's showing that Siberia has been having a huge heat wave, and it's not stopping yet. And so that's another reason that we're seeing this sea ice melt so quickly around this Russian border. And then around Greenland, This west side is about melted completely. The Baffin Bay is diminishing quickly, and then on this east side this is thin here, and up by the coastline it's quite thin or melted through already. The thickest ice we're seeing just on this northern edge of Greenland and this northern edge of the Canadian islands here, going from a little bit of red and then yellow and then green, and then we're headed back to the 2 meter range here, well before we get to the North Pole here. So the majority of the sea ice is under 2 meters. If we look, here's the North Pole, and so on the upper quadrant all of this is pretty much under 2 meters, and then a lot of this is under 2 meters. We can see the darker area here as well. Here the Hudson Bay is melting from the top down, and this Hudson Strait is almost all clear now. We can also see that the Bering Strait between Alaska and Russia here is almost completely ice-free. It's just got a little bit of light lavender here, meaning very thin sea ice. And the Alaskan border is ice-free here up to about, this is Barrow here. But we're seeing in this Beaufort Sea area that the ice is being pushed down and it's coming pretty much up to the coastline. This time last year we were seeing a lot of open water here, so that's a difference this year. So from year to year the pattern is going to be a little bit different, and the melt will be a little bit different depending on the air temperatures, the sea surface temperatures, what's going on underneath, like with volcanoes and earthquakes, and how warm the ocean water coming up from the Atlantic and from the Pacific are coming in, and how much concentration of the salt, the salinity, because that will make it melt faster as well. This is from the Navy website. This is their 30-day animated GIF. It starts from May the 1st, and so that's the data from May 1st through the 23rd, and then it projects forward until the 30th, or May 2nd. It's the 1st or the 2nd. So they're anticipating a lot more melting right up here in this quadrant closer to Russia, and you can still see it kind of scooting down. So that's what they're showing. Now this is from NASA Worldview, and they have changed their sea ice concentration. I'll show you this. This is why we're seeing all this red orange here instead of blue. I hadn't looked in a little while, but back on March the 25th, was the last day that they were using this layer of where is it? This sea ice concentration layer with the blue, showing the blue. And go for, uh-oh, I didn't mean to do that. Hang on. I hit the wrong thing. So here it was on the 25th, and I showed that already. And then starting on the 26th, they didn't use this layer anymore. I don't know why. So, but they have these other layers for sea ice concentration, and so I've looked at those, and this one is sea ice concentration 12 kilometers, and this analyzes it in segments with microwaves, 12 by 12 kilometer segments, and this layer analyzes it in 25 by 25 kilometer segments. So I chose the 12 by 12 segment, thinking that we might get a more detailed reading on this. So it's still concentration, but we have to get used to looking at red and reddish orange instead of the blue. Now let me show you the graph over here. The white is 100% concentrated, and then when you start seeing just the light pinky, light orangey, that's coming down in concentration. That's about 97%. Then when you're getting more red, that's getting less concentrated. Just like when you got more blue, it got less concentrated on the old model. And like this bright red, that's like about 90% concentration. And then as it becomes less concentrated, it changes to orange. Then yellow is about 75%, green is 61%, aqua is about 45%, then this navy blue is about 30%. Then when you get into the purple range, it's 20% and less. And so what we're seeing, we will see more colors emerge, I'm thinking, as this melt speeds up. But you can see around the edges, when we zoom in, you can see the details on how concentrated. And when I zoom over, like I've got my pointer there, that's at 45% concentration. And so on. So that's what I'm going to be using now. But let's go. So here's May 23rd, but they're a couple of days behind on this layer. Here it is on the 21st. And so we're seeing here the differences. This is Svalbard and this is Franz Josef Land. So we can see where it's melting, and it's quite thin here, or getting quite thin. And here's Novaya Zemlya, and so on. So we'll look at this in a little more detail in a minute. I just wanted to show that new layer and explain explain why I'm using that now in some details. So what I did was I made a couple of movies to reflect since March the 25th, since that was the last day that I'd shown sea ice on from NASA Worldview. So this first movie is March 25th through April 24th. So here's how it was moving and shifting, and we can see a lot of changes here in these tributaries. So by the 24th, it started to really melt on this Russia side, and up here in the Bering Strait and the Bering Sea. Now in this movie, it goes from April 25th to May 23rd. Now, as it goes into mid-May, you're starting to see a lot of different colors move in, and you're seeing the sea ice starting to retreat. And so these colors, we'll just have to get used to these. Here in the Hudson Bay, you can see the different colors shifting and moving here as the ice starts disintegrating. And up here over this East Siberia Arctic shelf, we're seeing a lot of changes. Now with methane, we've been seeing huge methane releases near Severnae Zemlya here, kind of constant, and here in the Kara Sea since January the 1st. I'm going to pause this when it gets to the last day. Here we go. So this is where we are for the 21st. And I can blow it up. Oh, it starts it over again when I blow it up. Anyway. It's kind of interesting to see the different colors. And you can see it shrinking. Watch the shrinking now. This is from mid-May on. So it's really cleared out since mid-May here in the Kara Sea. So there's that. Now let's go back to NASA Worldview. So I think we're done with that layer. So let's just take a peek at the sea ice up here. And remember, we've got to discern the ice in the clouds, discern through those. But we kind of know what to look for by having already seen those other models. So here it is from today. This is the Arctic. Here's Norway. This is quite open water here. Here it is around Greenland. This is clouds here. So we can see the southern tip is ice-free, and around to the east it's there's just a little skim of ice here with a few chunks, but they're counting that as sea ice and extent. Let's look over here on the western side. This is a cloud, so this coastline is ice-free here. And over here on the western side of the Baffin Bay, there are chunks of ice. It's very broken up. We're looking through clouds here. And then this is open here. And then it's still frozen through this channel here. So here's northern Greenland. We can see that the snow, there's not a lot of snow cover there. This is pretty rocky terrain, and we can see here this is this is an area, this northeast corner, where it's already melted through. Let's see if we can see. And here it was from yesterday. This is a lot less clouds. Look at this big crack already coming across. And so this is the area where we saw the thickest sea ice around, coming from northern Greenland across these Canadian islands. So the thickest part is right through here. But see, it's already breaking up, even at the thickest. That's a huge area that's already broken apart. And remember that it's sunlight in the Arctic now. Sun is shining, and it will be shining for the next few months. It doesn't go down. So this area will be constantly in the sun and receiving radiation and heat. Here's the Mackenzie Bay. Here's where it's breaking up. Here's Alaska. Here's Barrow, the most northern tip. Here's the coastline. Let's go back to today. Oh, let's see if that little part is available. No, we can't see. Can't see the Bering Strait yet. But you can see around it a lot of blue. Here it was yesterday, looking through clouds. That area you can see is obviously no ice there. Let's look. Okay, here's fewer clouds on the 20th. These are clouds, so it's pretty much ice free here. You can see that. Around this Alaska coastline. But here's some ice here further south, but right up here there's not ice. This is the Chukchi Sea here. Let's see. So you can see this ice edge, a definite demarcation there. So here are we back today. Here's Wrangel Island. This is a big area to the east that's ice free. Let's see if we can see that a little better. There we go. Here it is from yesterday. Yesterday it was there were a lot less clouds. So in certain areas we can see big chunks of areas where we can see the open water. Here it is off the Siberian coastline. We're looking through clouds here, so this is ice free through here. Now they run icebreakers through a lot of this, and a lot of these like very definitive edges, it's because they run an icebreaker through it. So wherever they run the icebreaker, that's going to be melting first, obviously, if it had frozen back. Here it is today. Now here's Severna, which is this group of islands with, there are a bunch of ice caps here, including the Vovolov ice cap that has been just pouring into the ocean. We can't really see that right now, but I'll be showing that as it clears up. Here to the west, it's or west from this view, there's very little ice there, you can see. So the methane is spewing up all around here and over here. So here's Franz Josef Land. Looking through the clouds, we can see the ice edge here. Here's Svalbard. Now you can see this western side here that's not in the clouds. And here's the ice edge. Here's Novaya Zemlya. Here's where it's right along the coastline. See, it's breaking up there. This western side is totally ice-free, and it's melting quickly on this northern side. We can see how that area is growing wider. And it never froze back on this western side. Now this is where we saw extreme melting since mid-May, right along in here. Here's the Yamal Peninsula. This is the Gulf of Ob here, and that's cleared out, and all around here is clear. Let's look at yesterday. Here we go. And this is a cloud here, so they're just little trailings of ice pieces here. So this is the area that has been so much hotter, this area up here. And it's the heat zone has been moving around, but generally it's been right up here. So that's what I had to show you on the sea ice, I think. Let me see if there's anything else for this moment. Can't really see that much as far as cracks and things here. This is the North Pole where all the lines come together. That's at 90 degrees north latitude. We're seeing the cracks here. Now, when we get into the clouds, of course, we have to differentiate clouds from ice. This is the 80-degree north latitude line. So here's the sea ice, we can see the cracks, and then here's where the cloud comes in. It looks 3D, where you see the cloud there. It took me a long time to learn to read this sea ice. I started a couple of years ago. When I first looked at it, it's like it's all white. I couldn't make out anything. But I just kept studying and looking at it and watching the weather patterns and learned what to look for. So there's that. Now we're going to go over a couple of articles. I'm going to start with this one from Gizmodo, and it's called "It Hit 80 Degrees in the Arctic This Week," and probably a lot of you are familiar with this, but in case you're not, this is from the 23rd today. And we can see here's the Arctic Ocean, and here's the brown, which is warmer than normal, and then the red is a lot warmer than normal. And this is the area that I was just showing you. Here's Novaya Zemlya. Here's the Yama Peninsula. Here's Siberia. And so this area has been moving around and then down as well. The story will provide important context for the headline, and I encourage you to read it, but really the headline tells you what you need to know. It was 80 degrees Fahrenheit above the Arctic Circle this week, which is, it's unheard of. A little farther south in Siberia, you know, the region of the world we reference when we want to connote something cold, it was 86 degrees Fahrenheit. Arctic sea ice in the neighboring Kara Sea took the deepest May nosedive ever recorded. Oh, and random swaths of the region are on fire. Things are extremely wrong. Let's start with the heat above the Arctic Circle. Mika Rantanen, a researcher at the Finnish Meteorological Institute, flagged a map showing blistering heat across western Siberia. The region has been the epicenter of an explosive heat wave that has rippled across the Arctic this week. Models forecast temperatures there will be as much as 36 degrees Fahrenheit above normal for this time of year. The heat could break a bit by the middle of next week, but widespread warmth will continue to grip the region. And what happens is when it heats up like that, then the ground has so much permafrost in it that starts melting and releasing a lot of methane and CO2. And we can have methane bombs go off, explosions, and big holes open up, sinkholes, and then you start seeing the permafrost moving across the landscape and, you know, running over everything. And then once the permafrost starts melting, then all the infrastructure starts breaking down. So this is a typical problem that we've seen for Russia and Alaska mainly, because there's so much permafrost up there. Here's a tweet about the western Siberian temperatures. 26.4 C as north as Arctic Circle, 66.6 degrees north. and 30.1 C at 62.5 north. On land, it means wildfires continue to spread. Pierre Marcus, a satellite monitoring expert, has kept an eye on the series of increasingly odd fires above the Arctic Circle, a place known more for ice than fire. Most of the blazes he's documented are on the eastern portion of Siberia, which also dealt with its fair share of heat all year in addition to low snowpack. Seeing fires burn next to braided rivers and large patches of unmelted snow is truly a mood for our current era of climate destabilization. And they found that these fires were smoldering under the snow, that even with it snowing up there, that the fires from last year were not completely put out. Then there are the ocean impacts, because climate change doesn't just stop at the water's edge. Warmth has washed over the seas that border Siberia, and the Kara Sea north of the western part of the region has seen the most precipitous decline in sea ice. After a slow decline in the first part of May, warm air has fueled a stark decline in sea ice, and we saw that just now. As of earlier this week, ice extent was the lowest level that's ever been recorded in May. It stands as a stark outlier, especially when looking at how ice behaved in the 1980s. I'm old enough to remember when the ice in the Kara Sea used to decline in July. This is from the writer. Numerous other seas that ring the Arctic have also been losing ice, and while they're not at record-setting levels like the Kara Sea, the Bering and Barents Seas are both at some of their lowest levels on record for this time of year. And this is from Zach Labe. This is the Kara Sea. Here it is, lowest ever for this time of year. Here are the other lines. And these impacts are the latest in a litany of climate horrors for the Arctic as a whole. Last summer it reached nearly 95 degrees Fahrenheit above the Arctic Circle in Sweden. The same summer, the mercury hit 70 degrees Fahrenheit at the northernmost settlement on the planet. Greenland also melted and burned. That's just some of what happened last year. I could list the same for 2018 and 2017, and you get the point. I have to be honest, I'm getting sick of writing these stories. The Arctic is warming twice as fast as the rest of the globe, and what's happening there is unprecedented. But how many ways can you talk about the fact that the Arctic is just extremely, massively fucked by climate change when the impacts are relentless? After a while, the degrees above normal start to feel normal, and the records are ephemeral, set to broken again the next year. But here we are with just another absolutely outlandish occurrence. I'll keep writing about them, because even if the records start to blend together, that in itself is a sign we really need to get our shit together and cut emissions now. Well, I guess Micah doesn't realize that cutting emissions is not really the answer. Anyway, there's that story. This is from the Washington Post. Parts of Siberia are hotter than Washington, with temperatures nearly 40 degrees above average. Snow cover is disappearing, sea ice is melting, and fires, including possible zombie blazes, are raging. This is from May 22nd by Andrew Friedman and Matthew Capucci. Let's go to a clean view on this. January to April temperatures from average, showing the most significant temperature anomalies across Russia, including Siberia. So, yeah, we can see the hottest right up here. And I've been showing this every day On my daily updates, there's Andrew Friedman. Siberia is in the throes of a heat wave that would be considered warm even by the standards of those living outside the Arctic Circle. In Washington, for example, the temperature has been stuck in the 60s all week, reaching a maximum of 73 degrees Thursday. Yet several stations in north-central Siberia, including areas near or above the Arctic Circle, are seeing temperatures climb well into the 80s. On Friday, the town of Khatanga, Siberia, located well north of the Arctic Circle, recorded a temperature of 78 degrees, some 46 degrees above normal. The typical maximum temperature for the day at that location is 32 degrees. The town obliterated its previous record high for the date of 54 by some 24 degrees and its monthly record of 68 by about 10 degrees. The Siberian warmth in May is not a fluke event either. Instead, it's been a constant feature since the winter. Temperature departures from average in Europe and Asia have helped push global average surface temperatures to record highs this year, and on global temperature maps these regions stand out as splotches of crimson red. The warmth in Siberia is already having repercussions on Arctic ecosystems, with unusually large Siberian wildfires already burning this year. Snow cover plummeting unusually quickly and sea ice cover in areas such as the Kara Sea, which lies to the north of central Siberia, at a record low for the date, having begun its seasonal melt more than a month earlier than is typical. In recent years, scientists have raised growing concerns about the stability of Arctic permafrost, including stretches of permanently frozen soil located throughout Siberia. That's what I was talking about. When the permafrost thaws, carbon dioxide and other planet-warming greenhouse gases that have been locked away for centuries is freed up, constituting an accelerant to global warming. Scientists refer to this phenomena as the somewhat innocuous-sounding positive climate feedback, when in reality is not a good thing. According to Zach Labe, a graduate student at the University of California at Irvine, who researches Arctic climate change, what has recently been taking place in Siberia has been extraordinary. Although Siberia is known for wild temperature swings, the persistence and magnitude of warmth over the region so far this year has been astonishing, he said via email. This week is an example of an extreme event, with summer-like temperatures over parts of western Siberia thanks to a strong upper-level ridge. We can already see this reflected in snow cover data, as there are large negative departures of snow extent stretching across the entire Siberian coast of the Arctic. Labe noted that ice in the Kara Sea has reached a record low for the date, and ice cover is thinner than average along the entire coastline of northern Siberia. He said the warmth is likely conditioning the ice to melt further by melting snow cover lying on top of the sea ice. So we just saw that. The intense ridge of high pressure or heat dome it parked over Siberia. Apparently there's a picture there. So there's a heat dome over there, which we saw. The polar vortex has moved around, etc., etc. So you get the idea. And here they quoted Mika Rantanen, and so you get the idea that this is just the beginning of the melt season, and it kicked off a month early, and now here we are. And we saw the Greenland ice sheet starting to melt way too early as well. And there we are. So this is what we're in for. And in spite of the lockdowns and cutting emissions, and are we seeing the effects of cutting emissions and the losing the aerosol masking effect? I don't know, but I do know that I haven't seen any more large areas of clouds of sulfur dioxide over the northern hemisphere in the last month or so. That's cleared out, and but we're starting to open back the world, the economy, the world, industry, whatever you want to call it, and repolluting. Although I want to point out that even though emissions were cut, we still were producing as much electricity. We were just using it at home instead of in our workplaces, in the office. So the coal plants making electricity in different places, those didn't stop. And so it's not just about cutting emissions. It's a whole thing. And are we too late? I think we are. But I don't know. I'm not a climate scientist. Here we can see a little bit more here in this Bering Strait. They're a little late getting that last little piece of data up here. But that's my report for the Arctic sea ice for today. So I think time is short. I do believe we are in the end times, and that we need to get our spiritual house in order. If you've not gotten right with God and Jesus, now would be a good time. So I'll talk to you real soon. God bless you, and go in peace.